Let me walk you through the definitions for maximum and minimum values on some interval. So the definition says that we're going to let f be some function which is defined on some interval I. Okay, and now the items on I are elements of the real numbers, meaning that we don't just have some interval of, let's say, just rational numbers or irrational numbers, whatever it happens to be. Now, if, okay, now there's two cases here for the maximum. So we'll call this capital M for the maximum value of the function. Now, capital M is an actual number, so it could be like 2 or 7 or 3.6. Who knows what it is? But M is an actual number. Okay. Now, if the following two cases hold. Okay, so if f of x is less than or equal to that capital M for every or for all x values in the interval. Okay, what this means is that the function height values are less than or equal to some m value for every single x that we could possibly plug in here on the interval. I'll draw out a picture of that in a second. And two, if there exists some x naught that when we plug it into f, we get m out. So we'll say there exists at least one x naught in I such that this holds, then these two things together imply that m is a maximum value. On I. So let's just draw this thing out, okay? So here's what's going on. Let's say we've got some function, okay? And it looks, I don't know, like this. Well, actually, that might be confusing for you. Let me go like this. Okay. And then let's say that we define it on some interval. So here's x. We define it on some interval, let's say from here to here. Now this interval from, well, let's just call this A to B, okay? Like that. Now if there's a situation where we've got, for every x in this interval, all of the function height values, like, so let's say for example we take this x right here, then it has a height value of f of x, right? X, f of x. And maybe we grab this guy right here, and this guy has a height value. Let's call this guy, I don't know, not A, I don't want to use A again. Let's call this guy x0. Well, let's not use that because that's used here. I'm going to run out of variables here. Let's call it x1. So here's f of x1. And let's call this guy over here x2. So here's f of x2. Now, if it's the case that every guy on this interval, no matter which x value I plug in here, if it's the case that f of x, no matter which x I pick, if x is just on that interval, if all the function values are less than or equal to some real number m, okay, for every single guy on there, and it's also the case that there exists an x sub naught on there whose height value is equal to m, then m is the maximum. So what we're seeing here is maybe this guy right here looks like the max, so we'll call this guy x naught. What I want you to notice here is f at x naught is the highest, okay? Is the highest out of all of those guys. And so we'll call that value m, which is the maximum of the function on some interval like that. Okay, so we define our maximum as the guy that has the highest value on some interval, whatever it happens to be. Now we can do the same thing for a minimum as well. So for a minimum, we just rotate signs. So for the minimum, we just say that this has got to be like this. Every function value is greater than or equal to the minimum, and that there exists a guy out there that's equal to the minimum value. Okay, and that's it. That's all that there is to defining a minimum or a maximum on some interval.